Good morning, everyone. I would like to welcome you in this first workshops. It's a very big challenge to be in kind of a country that it doesn't have any water resources. And about 80 years ago, we introduced the ministries or the kingdom introduced the first desalination plant was in Jeddah. It's like about 300 meters a day. Today we are producing almost 6 million cubic meter a day. We are the leading country in producing the desal water, and in the same time we have the biggest desalination plants. We have the biggest desalination plants in the world, and we aim to cover every I would say every city in the kingdom with the desaled water. This is one of the biggest challenge, where is the economy is increasing, the population is increasing, and I would say standard of living is increasing, which is a very good for this country. However, is a big challenge for providing water. In the same time, we are aiming to integrate the water resources in the kingdom in implementation. So we are trying to find a way to use the water more than once to produce food, to increase or controlling the environment by irrigating some of the agricultural products and trees and municipal recreations. And this is that's where is the importance of kind of this research, or this research is. Still, desalination is not cheap to produce a cubic meter of water, and that is definitely is one of the burden. However, in the last few years, we see a dramatic decreasing of a pricing of a cubic meter, and the sky is the limit for depending on the innovations to reduce the price and to see of the what we call the byproduct of the water that can definitely reduce the cost of the produced water that is necessary to human living in the kingdom. With this a little bit of a speech, I would like to welcome everybody in this workshops, and we will start with introducing everybody so we can know each other. My name is Mohammed Al Saud. I am advisor to His Excellency the Minister of Environment, Water and Agriculture. I have been working in the water sector for, I would say, about 25 years. And I will start with Dr. Ahmed.
My name is Ahmed Al-Hanoudi. Right now I'm Director General for Dissemination of Technology. I have been working in this field for about 28 years. I hope that everybody hear me. Or I have to repeat what I have said. Okay, thank you very much. No, it's okay.
My name is from Saudi University. I'm assistant professor at King Saud University in Civil Engineering Department in Water Resources Engineering. Been consulting in a couple of agencies, rock and Ministry of Water Resources and Water Utility. That's where I mainly worked in groundwater and policies, and I worked in the water network and pipelines too.
I'm Abdul Hakim Al-Turki, head of water regulation in MIWA. Actually, I've been working in water sector from maybe 10 years or 12 years. This is my working exactly actually, and my specialty is water technologies between actually water desalination and water recycling and the merged technologies between them.
My name is Adrez Gabao. I'm assistant professor in Adrez University, the hydrology and water resource department.
My name is Eid Al-Mukraki. I am a assistant professor at Adrez University. My research interests primarily around solar desalination applications, and that's what I'm trying, inshallah, to this workshop.
Good morning. My name is Ibadan. So I'm associate professor in the department working in the Center of Excellence in Desalination Technology. So currently I'm involved in TFC, biocompatible TFC method for RO, and as well as we are also engaged in electromagnetic desalination also.
دكتور محمد حسين البيروتي. أنا من جامعة الملكة عبد العزيز قسم هندسة ميكانيكية و founder of Center of Excellence in Desalination Technology for the last 10 years, and أنا الآن متقاعد ولكني متعاقد مع الجامعة، وعندنا أبحاث مع الوزارة يعني، وهذا واحد من الدول. Sorry, I'm speaking in Arabic and I forgot about English, which is a big problem. Okay. Mohammed Al-Beiruti, and I've been involved in desalination technology through the Center of Excellence in Desalination Technology. We actually lately won a grant from the Ministry of Education, and we're talking about this today, which is integrated systems in desalination. And it's a big project, and it's composed of 4 different sub-projects. One of them is the roadmap development in desalination and water reuse in Saudi Arabia. And this is the first workshop, which is we are going to talk about this today.
Assalamu alaikum. Hamad Shiban, research assistant in the Center of Desalination Technology.
Assalamu alaikum wa rahmatullahi wa barakatuh. Engineer Ayman Al-Nu'mani, engineer in the center, in the desalination, the center.
My name is Dr. Hani Bulkhair. I am now the director of Center of Desalination Technology. I am also an assistant professor in mechanical department. Inshallah, we will have like a good talk from Dr.
Good morning, everyone. My name is Nikolay Voutchkov. I'm a senior expert with DTRI, the Desalination Technology Research Institute. I work with Dr. Al-Moudi on a number of projects in brine concentration, optimization, and operations of desalination plants, as well as many other research projects, energy recovery, and others. I also participate on the 2 key ongoing roadmaps developed in the U.S. at present. And one of my presentations will focus on what are the topics and issues, and what is the vision of the U.S. for desalination in the future, which I'll be presenting. Otherwise, I have 35 years of experience in this field. I graduated from UCLA, which is University of California in Los Angeles, and I've been working as a consultant and also as a chief technology officer for a large U.S. company developing desalination projects in the U.S.
Assalamu alaikum. My name is Omar Ahmed Bamaga. I am associate professor in the Center of Excellence in Desalination Technology since 10 years. My research interests are on emerging desalination techniques like membrane distillation or osmosis, integrated membrane processes, now we have started also one project on membrane condenser. I am pleased to be with you today in this function.
With this, I think we'll start with the first session. Dr. Ahmed Amoudi will lead this session.
I hope that you will have enjoyable and fruitful session from it. I would like to give the floor to Dr. Nikolay to talk about the Thank you.
Thank you, Dr. Alamboudi, for the kind introduction. Let me change the slides. Well, thank you for your time and attention. I would like to, I have two sessions that I would like to cover. One of them is actually giving an overview of ongoing desalination roadmaps in the US, which desalination certainly have gained a lot of attention during the Trump administration in 2019. He made it a major focus in the country as a renewable source, as a water supply source. And the country decided to develop a very large desalination program in the next 5-year research program. In the next 5 years, the focus will be in one of the research institutions to invest $20 million in research every year for the next 5 years to specifically address various issues in desalination and to transform the desalination industry. So I'll present. I'm on the board of the trustees of this activity, and also I'm working for another with another research institution, the Water Research Foundation in the US, who also is focused on desalination, and they are developing a roadmap. So I'll show you what are the roadmaps, what is the procedure and process they follow to implement the roadmaps, and what are the focus areas that they're interested in. They, I think, would be a good background for us to think about what is relevant to us here in Saudi. Obviously, every country has its own focus and interest, and what the rest of the world is doing in this field. So we'll begin with the overview of existing of those two activities. Thank you. All right, well, we'll talk first about the Water Research Needs Project, which is developed by the Water Reuse Foundation, Research Foundation. And who is the Water Research Foundation? It's one of the main developers of new desalination science and technology. It is actually cooperation of a number of agencies. They're public and private, public utilities. In US, we do believe very much in public utility ownerships. We're not into privatization. Although we do have private entities, we do believe that water is a very important strategic resource and it has to belong to the public. Although we are the biggest capitalist country in the world, we don't touch water. We believe it's a sacred source that has to stay with the public because it's for the public good. So various research organizations and also public utilities collectively have put together Water Research Foundation. What they do is on an annual basis, they contribute. Those are the utilities. We have over 1,000 utilities, 1,049 utilities. We do have also a number of other institutions, research and others. Every member contributes every year a certain amount of money, and that's based on the size of the utility or the size of the research institution or the revenue of the private business. So this money is contributed into a common place, into a common, between the Water Research Foundation, and then the money collected is divided into projects. In average, we have about $5 million every year collected from the subscribers, and they are divided and focused on desalination research. So that's what this association does. It is focused on understanding the needs of the public utilities and private sector in. Okay, thank you very much. All right, so what the Water Research Foundation produces is research reports that address topics that have been identified through a roadmap. And they usually do the roadmaps once every 5 years, 3 to 5 years. So they define the new topics and objectives that utilities would like to have covered. Those reports are available to all the subscribers for free. In addition to that, they're available actually from their internet site for purchase. They're research reports, but focused on solving real problems, real issues. They're not as much focused on fundamental research. They're focused on solving issues and topics that are most important to the public utility subscribers in the country. So the latest desalination roadmap was started last year.
And the purpose is to evaluate the state of science at present in desalination. And in the US, besides seawater, we do have brackish water as well and other sources. So this also covers those other alternative sources. We do also have a lot of produced water because we do fracking. Fracking is oil exploration approach that different from what we have in Saudi Arabia, but ultimately produces a lot of water that is waste and has to be treated. And then we also focus on concentrate management. Those are the key areas of water research that are of interest at present. So what we're trying to do there is identify timely and compelling research needs. What is needed by the industry to address those sources of water and producing them at lower and competitive pricing. At this point, the focus is the research for the next 2 to 3 years. Today, the consideration of research community in the US is the topics of science in the US are advancing very quickly. So every 3 years, sometimes the focus changes. So there's some themes that are common, but every 3 years it needs to be updated because new topics come up as we develop research in science, and they have to be incorporated. So science in desalination is growing very fast and changing fast. That's why every 3 years is a good, 2 to 3 years is a good time to do updates. So the purpose of the roadmap is to prioritize and identify projects that are of high value to the Water Research Foundation subscribers, to the public utilities, to the research institute and private sectors. I'd like to present to you what was the process, how did they develop, and they're currently developing it, it's not done yet. How they develop the roadmap, what are the key steps they took? First, they created a steering committee to oversee the research needs, and that committee is of experts in the desalination field. I can proudly say I'm one of the members. There are 5 members of that committee. And the purpose of this committee is to steer the direction of the development of the roadmap. And one of the things we did as part of the effort, because most of the people on the research committee are very busy people, they don't have the time to write lengthy roadmap documents, we actually have retained a consultant through a procurement process, which does a lot of the work associated with writing, preparing for workshop, and other activities. That consultant is actually a engineering consulting company in the US. We selected this company based on procurement. We've prepared a request for proposal, submitted it to everyone that's interested, and we had 5 companies submitting, and based on their scope and proposal and costs, we have decided that to select one of them. So one of the purposes of the steering committee is to make that selection. So number 2, we have created the steering committee, we have procured a consultant, and the very first thing that the consultant had to develop is we call it State of Desalination Science Report. What that is gives an overview of all key issues at present. What are the key issues and concerns in desalination, both in science but also in policy, in permitting, in creating in environmental impacts. So we look at it very holistically. So this consultant develops this report to facilitate a next step, and that is actually a workshop that identifies the actual key topics of research. So the desalination of state of science report is really just to give people ability to look at a document and say, okay, well, what has happened in the last 5 years? What is the new research? What are the new topics that came up? So this is all summarized in a report that gives people the understanding of what are the latest concerns and takes a look at how close those concerns are to what we do. As part of the State of Desalination Science Report, there is one step that I didn't show here, which is actually survey. When the consultant was appointed, they wanted to know, out of those subscribers, what are their key interests? What are their key areas of concern? So they developed a questionnaire and sent it to all the subscribers, as well as to experts, and this was both internationally and nationally, asking them to address what are their main concerns and issues. Based on this, the responses from the questionnaire that they compiled, they actually developed the State of the Science Report. So they took all the common themes, all the common topics, and consolidated them in set of topics, which came as an input from everybody that had been approached. And this is over about 2,000 institutions and utilities and experts to say what they think. So the consultant consolidated that into several topics and then created the state of the science report around those topics. They wanted to cover specifically the topics in the field of research that were of interest to the members of that group of utilities and other subscribers. The next step was to complete the roadmap workshop. So once they created the report, they distributed to everyone, and they decided to invite a group of about 40 to 50 people, experts within the industry. Some of them are key subscribers. Others are regulatory agencies, ministry representatives. We don't call it ministries in the States, but we do have equivalent to that. We call it departments, which is the same thing. So the Department of Interior, the Department of Environmental Protection Agencies, all of them had representatives on the workshop that ultimately would create the specific, out of the key topics, first agree that those are the key topics, and second, create actual projects that would be then pursued for investment and development. So once the workshop was completed, all the input, including identified projects, was summarized in another report called Desalination Research Need or Roadmap Report. That report ultimately is made available to everyone, and this report and the projects in it were used to actually fund the research for the next 2 to 3 years. So basically, this organization for 3 years has $5 million per year, and based on those projects that were identified, they would actually fund the projects based on the priorities established in the workshop. Because in the workshop we have teams, we have developed projects between the teams, and we also prioritized those projects and also established what will be the approximate budget for each of those projects. So then we figured out, okay, well, we have this many $1 million of good projects to fund, and we have $5 million a year. How do we match it? So that's done by the Water Research Foundation. So that is actually what happens with this roadmap. Roadmap is used for two purposes. One is to educate people, to use it as a guidelines from various institutions, but the other one is actually to be a source of direction for funding of specific research that addresses the key issues of interest to the subscribers and to the industry in the US. So steering committee was, yes, if you have a question, yes, go.
Within the direction or after direction? The question.
Between, you could ask questions at any time.
Question about the key steps for the roadmap. Is these steps are parallel or
they're sequential. They're sequential. Yeah, the very first was to create the steering committee. The steering committee selected the consultant. The consultant then developed the questionnaire and sent it, completed the survey, collected all the responses from the survey, and then consolidated them into about 8 topics. Because different people have different opinions, and they were consolidated in 8 topics. Those topics were then put into this state of the science report, and around these topics they presented what is the latest in science on this topic, on every one of those topics. Yes?
The missing steps, which is very important, which is creating the survey.
Yeah, I'll talk a little bit more about it. Yes, there is a survey that was done right after the procurement of consultant right here. I'll talk a little bit more in detail about that. That is correct, yeah, the survey is important. So about the research steering committee, it was appointed by the Water Research Foundation to direct the process. This research committee actually was appointed. They do not get paid except for the travel expenses, so this is volunteers. The 5 members are selected based on their expertise in industry experience and recognition. And then they work with the project team to ensure scientific integrity, to make sure that the selected topics are the right ones and they're prioritized accordingly. They do select the consultant to prepare the state of the science report and assist the workshop program, making sure that what we have in the program developed by the consultant is accurate and representative of what we need to do. The procurement of consultant was done through, basically through a competitive procurement process. We did an RFP, invited consulting companies to respond, and we selected the consultant through a competitive bidding. This consultant was paid about $35,000 for the involvement, just to give you a sense of what we paid to the consultant. The consultant scope included literature review, survey of the members of Water Research Foundation, preparation of state of the report, conducting the workshop, and also the preparation of the actual roadmap report.
Can we interrupt with the questions during your talk?
Yes, you can, as long as you have your pajamas and you want to stay here for late. I have about 45, 50 slides. So depending on how much you interrupt me, we'll stay here for a long time or a short time. I can speak about, I'm involved in every step of this process, so I can answer any question you want. It's a matter of how detailed you want to go.
I think after the presentation for me, because otherwise
Is better?
the will break up.
It's okay after the presentation, please. Otherwise,
Otherwise, you have to carry your pajamas here, and we'll go into pajama party process. That's what we call after 6 o'clock when we have to work late. In any case, just to talk about the survey a little bit. Survey of the members and project participants was very important. Audience is to promote worldwide academia, project service providers. So we approached everybody. We approached the consulting companies. We approached the public utilities, also the science community, universities, and other research centers to make sure we are all inclusive, including equipment manufacturers. They are on the forefront of developing technologies. We want to make sure we know what's happening with them and what their interest is. And the scope was to inquire about relevant and critical research needs in various regions, and not only in the US, but also in other countries. And the request suggested research concepts and also address technical topics and non-technical topics, including regulations and policies associated with the implementation of the project. So what are based on the survey of the Water Research Foundation members, the key areas of interest that surfaced were sequester marketable constituents from brine. Basically, there is a great interest in the US now in beneficial extraction of materials from brine, of metals, of various types of valuable compounds that can be used in the industry. Then reduce energy consumption or use of renewable energy. That is a very important topic as well. Desalination is still the most energy consuming type of water production technology. Then reducing energy is still a very important goal. Then the next one is selective removal of specific contaminants and also selective membranes and absorbents. One thing we find is as we go into membrane concentration and extraction of particular valuable minerals, we find that we need specialty membranes that are dedicated to doing certain things. Currently, we do that through ion exchange, but ion exchange is very expensive. If you compare membrane technology to ion exchange technologies can extract the same metal for about 3 to 4 times the price of membranes. That's why now the focus is how can we selectively extract particular elements. For membranes, that is actually not a very easy thing to do. Membranes of today are selective towards sizes of particles, not necessarily towards a particular chemical elements. So doing that requires rethinking the membrane design. Also, one other issue is fate of constituents in brine. What happens with the various substances in brine, and why is that important? It is because often when we create a product from the brine, the user of that product has a very specific requirements for the quality of that product. So we have to meet a particular specification. And we need to know from the compounds they're concerned about what happens to them through the treatment process, because they don't only care, let's say, of sodium chloride if they want to buy sodium chloride from you. They care also about all the other substances that are in your brine and particular constituents that you have that may be a problem to them. And then communications and public acceptance. In the US, desalination is not as widely accepted as here, believe it or not. That is because it's considered expensive, and it is considered environmentally more damaging than other water treatment technologies. So educating the public of what we do as industry and how we take care of the environment as we design our projects is very important. So we do actually have focus on communicating the work of desalination and our policies to the community so they can accept it. In general, decisions about desalination projects in the US are made at community level. If community is against the project, doesn't matter how good it is, how inexpensive it is, or how much the central government wants it, that's the end of that. Communities have a big say on if a project goes or not. So that's why making sure communities understand is important. So what are the key topics that were identified based on focus areas identified based on the input from the survey? Intakes, pretreatment of saline source water, desalination technologies, concentrate management, product water quality, energy and carbon footprint minimization, and project implementation. In some of our states, we actually have now requirements for like California, for the desalination plant to be carbon neutral. What is that? What does that mean? Obviously, we consume electricity. We don't generate carbon on site, but the expectation is the carbon dioxide equivalent of the electricity. Basically, every utility now that makes electricity has to declare what is their carbon footprint. For 1 kilowatt hour of electricity, how much carbon dioxide they emit. Based on that, and based on the amount of electricity we use, we have to calculate the total carbon footprint in tons per year of carbon dioxide of the desalination plant. And then we have to show how do we reduce this to practically zero. And there are various ways of doing it. We have developed a methodology in the States, and that is evolving. But that's what we are talking about, energy and carbon footprint minimization. There is a big push in making desalination plants carbon neutral. And then the last issue is project implementation. As here you see two models, private development versus public ownership and development of assets. There is still this discussion in the States. What is better? Is it PPPs, public-private partnerships? Is it public utilities actually owning and operating the assets? And project implementation and issues associated with that are still in discussion. They're open for project implementation, and issues associated with that are still in discussion. They're open for input and certainly an issue of consideration. So what are the issues associated with intakes in the US? In the US, we consider, and many of our regulations consider intakes as damaging to the species that live in the water by two processes: impingement, which means pressing the species against the screens of our intakes, and therefore they die or they get injured because of that pressing, and entrainment, which is once the marine organisms enter our water, they will go into the pretreatment and other facilities and they'll basically get killed. So those types of losses by impingement and entrainment are considered significant in the States now. It depends on where the intake is. And there are regulations to minimize that or compensate for that. Like, for example, Carlsbad Desalination Project, to which I was a chief technology officer, was required, because of the amount of marine organisms that were taken from the water, to create a separate lagoon that creates exactly the same biomass of marine organisms that would be taken by the intake. Very expensive to do. Actually, added about 20% to the cost of the project, but that's how US looks at it from that perspective. So anything that minimizes that impingement and entrainment significantly reduces the cost of the project in the States. That's why it is so important. Next is intake performance evaluation and improvement, and that's also related to impact on the environment. And then selection of optimum intake type and configuration. In the States, as here I've seen a number of studies done in Saudi Arabia, there is a big discussion of, do we want to go open intakes? Do we want to do subsurface intakes of various kinds? Which one is better for what conditions? Because subsurface intakes ultimately minimize environmental impacts because they don't impinge and entrain marine organisms. So selecting of type of intake for the specific conditions is one of the key topics people are interested in the States. The other key topic is pretreatment, fundamental understanding of foulants and fouling mechanisms. Despite the fact we've studied fouling for many years, and many of you probably have been involved in studying that. I know Dr. Al-Amouri has worked on that for many of his research activities. Fouling and understanding fouling is of critical importance. Now we switch from the point of how do we, the thinking is changing. It used to be that we add chlorine and we eventually win the fight against bugs by killing them. One thing we've learned over years, you can't really win that game. Basically, marine organisms are very, very resilient to chlorination and many other methods of destruction. Most of the biofouling organisms are called alpha protobacteria. They were the very first living creatures in this earth. They were exposed to extreme conditions of ultraviolet, for example, irradiations, extreme conditions that don't exist today, but they adapted to. So they're very difficult to destroy. So what we're doing now is saying, just forget about killing them. Let's figure out how do we basically make them work for us. And by removing the organics upstream by bioreactors, for example, as we have with activated sludge, or by actually shutting down their fat gene. there was a very interesting research of one of the leaders of the other team that I'll talk about that figured out that there is actually a particular gene in bacteria that creates the sticky substances around them. And there is a way genetically by certain chemicals to stop that gene from activating. So at this point we're looking at, well, let's understand how bacteria work and not necessarily try to kill them, but to work around to suppress their ability to stick to the membranes. Number 2 is performance and cost improvements of existing pretreatment technologies. There are many technologies that do not work, like for example, dissolved air flotation has been built as a technology in many plants. None of the dissolved air flotation systems ever worked well, and I have actually done a study for a client in the United Arab Emirates about DAFs to check how they work, how much they remove. They're a complete failure, but we keep on building them. And there are very good reasons for that. So there is a lot of research that now is focused on what's wrong with DAFs for seawater. And there are many I can talk about that for a couple of hours, but very interesting topic. And now we are trying to learn how do we improve dissolved air flotation to make it beneficial to us? Or do we really need it? And what are the options? And there are various solutions that have been implemented worldwide that actually remove DAFs. Say, just forget about DAF. This is kind of an old thinking. It used to be a good thinking 10 years ago, but it's not. It's kind of an old thinking now. Number 3 is development of new pretreatment technologies. There is ceramic membranes and other methods of pretreatment. One of the researchers looks at pretreatment and says, we have all this bacteria and organics. Why are we trying to remove them? Just kill everybody. So basically the approach is ozonation, which burns bacteria and organics, and there's nothing left to pretreat. There's nothing that causes anything because they're all burned through ozonation. So those are the types of new methods of thinking that are not the conventional filtration. They're more intensified processes that now the industry is looking at. Of course, desalination itself is very critical. We have tried to build bigger desalination membranes, 16-inch, 18-inch, 19-inch elements in the States. We failed for a number of reasons. I can talk about that for another 2 hours, but ultimately what we concluded is this is not the right path. It's not the right path to go and build bigger elements that produce about the same amount of water per square meter. The right direction is to actually increase the productivity of the membranes themselves, of the surface layer. Because currently surface layers are created through a random chemical reaction. If we could streamline it and turn the surface of the membranes to look like a honeycomb, we could actually increase productivity of the same size with about 20 times. And that's where the focus is now. New materials, not new big membranes as we used to think in the past. So element and arrow. So this is enhancement of arrow membrane element performance. That's where the focus is. Optimization of the arrow system performance. Now the view, and in its view here as well, is how can we squeeze more water from the arrow system? We know today most of our desal plants are designed around 35 to 45% recovery. The future is in recoveries that are over 60%, 60, 75 and on. So that's how do we develop those systems. And then the 3 is development of advanced desalination technologies that are non-reverse osmosis, like aquaporins and other processes that have been attempted to, but not yet brought into success. It doesn't mean that they don't necessarily work. There is no easy solution, but but nature offers often very elegant solutions, like mangrove desalination separation or the aquaporin separation that actually could be a completely different way of solving the same problem. Concentrate management is now very, very important. For us to grow desalination, yeah, go ahead. For us to grow desalination business, we have to be able to get rid of the concentrate and not only just dispose of it, but also turn it into a valuable product. So we have focused on advancing brackish water concentrate minimization and low-cost disposal. Currently what we do in inland areas, we just dump it in very deep confined aquifers where the brine cannot exit, and that's what we do with it. Or if the project is relatively small in volume, we use evaporation ponds. Both of those methods are very expensive, and we have not considered those elegant solutions. So now we're looking at zero liquid discharge approaches, which could minimize significantly the volume of brine. Reduction of seawater concentrate disposal costs and environmental impacts. And then development of technologies for management of concentrate and other waste streams. Why are those important? For the same reason I mentioned previously. How do we turn brine from waste into a valuable product? Technologies are evolving to the point where we could actually do that nowadays. Product water quality is also a very important issue in the US. One thing we realize is product water quality has direct impact on human health. And that's why what we're trying to understand is, for example, desalinated water has less minerals than other sources of water. How is that impacting human health? We find that there are actually negative impacts. We've seen that actually happening in here. I participated 2 years ago in a research in Qatar that actually have found medical research found a statistical correlation between cancer and low salinity desalinated water. And that is going to continue for 5 years, and there will be hopefully the next year research. It's actually led by the Queen of Qatar because she considered that a very important issue. So those types of issues we start finding as well in the States. So desalinated water is not necessarily healthy water if it's not nutrient balanced. Developing strategies for corrosion control and blending of desalinated water with other systems. We find that when we start blending desalinated water with other sources like river, lake water, and other water, we start seeing chemistry that we haven't seen before. And we're learning to understand what happens when we mix it. And then optimizing water quality and costs. We can obviously produce what we call in the States designer water. We could add minerals of any type to make it look like Perrier, Pellegrino, anything, you name it. But that costs a lot. So where do we find the optimum between remineralization and quality that is at a reasonable price? And carbon footprint is certainly very important now. Development of RO energy reduction technologies. And those are from energy recovery, from switching some of the components of the desalination plant to work on solar panels. Nowadays, most of the new designs are, as you could see, this one here is all roofs of all the desalination buildings are covered with solar panels. Not that that makes a huge difference, just to tell you, based on our experience, if you cover all the roofs of all the desalination buildings, you'll get probably about 1% of the demand of the plant. So it's not huge, but it works. Second, advancement of energy recovery technologies. We're trying to squeeze more energy out of the brine. And third, development of new low-energy desalination technologies. Just looking at how do we desalinate water without using osmosis, because that is a very expensive process. Aquaporin is an excellent example of that, for which the discoverer of that process had received a Nobel Prize, where he found that besides reverse osmosis, there is enzymatic transfer of water through membrane cells, through membrane, in the membranes. And that is a very low, that enzymatic transfer is a very low energy transfer. It's 100 times lower than osmosis. So how do we harvest that? And then carbon footprint minimization. As I mentioned, in the US now we have to create carbon footprint emission assessment for every desalination plant, and then explain how we're going to go to zero carbon footprint. We're also now developing a market for carbon footprint trading, which is actually carbon dioxide credits that you could purchase on the market. Currently in the US, they're about $50 to $80 a ton of carbon dioxide. So you have to, if you cannot complete your carbon footprint reduction by other measures, you have to buy those. And the money that are collected, they're collected by the state and focused towards developing of new programs for green desalination or alternative sources of it. But the reality is designer designs it and goes away in 2 or 3 years once the plant is designed, and still operator's risk. So we actually do now, when we plan a desalination project, we require in the States at least 1 year of source water quality collection for the entire year for us to know exactly what's in the water, what are the problems, how different atmospheric events like rain, like winds, impact performance of the plant. Algal blooms, they do occur at different times, sometimes combined. And unfortunately, in this country, we don't do that, which I'm absolutely shocked to see. We just go and collect a couple samples and say, here's our water quality, just let's go and design it. Oh yeah, doesn't matter, water quality is not important. Actually, in reverse osmosis, water quality is the most important driver for the desalination plant design and optimization. And we actually do not understand water quality very well, and we tend to ignore it. So that's an important issue where they look at it. And then improving public communications is important, telling the public what we're doing and why, so they can support us and allow us to build it. And optimization of project funding and delivery. In the US, we do believe in public funding, and therefore the states have developed special programs to fund desalination projects, which are very low cost, like 1% interest rate. And they, through that, the funds are very attractive to the public and allow the public to benefit from the process, because otherwise private companies, the reason why they like privatization is because they make money out of funding. The returns on investment that they expect are 14 to 16 to 18%. And you know, when you see this cost of like of aqua power of 53 cents per cubic meter, this is complete Mickey Mouse stuff. If you see actually real cost of water over 25 years, the average first year is 53 cents. But first year cost means absolutely nothing. When you look at a 25-year project, the average cost of water is $1.28. But nobody tells you that. For whatever reason, your government basically is so focused on the first year of 53 cents, which is completely meaningless number, because basically the projects are backloaded. It's a little bit like, I don't know, here in Saudi, maybe you don't have that. In the States, when we buy a house, we have the zero interest rate, zero cost first year. We could make desalination like that to be zero, because everything is backloaded. That's very important. Privatizers often have to play games with the numbers, and then you end up being sucked into something that sounds incredibly good, but it's unreal. So we look at that and say, well, is that real? Let's open it to the public. Let's put it to a public discourse. What are the privatizers doing? What are they doing in the back, as to say, in the back room? And what are the real numbers versus what's being reported? In the States, we do have that. And we found that this is all bogus. Why? Because technology has not changed dramatically. The real cost of water is about $1. If somebody tells you it's 53 cents, you have to scratch your head and say, how is that possible? If you multiply the kilowatt hours of the plant by the cost of electricity, you can't pay, with 53 cents don't even buy you the energy. So you have to kind of apply common sense and say, well, there must be something wrong in that number. And that's where we actually, as an industry, say, okay, privatizers, put your cards on the table and let's see how you got to that point. And you guys don't do that. And you just keep on repeating, oh, 53, 49 cents, this and that, just nonsense that everybody says, oh, great, you're achieving extreme success. This is all Mickey Mouse stuff, as what we call when we say something that's unreal but looks good. And somebody has to take a look at that and address it. In the US, we do have the same Mickey Mouse stuff coming from the privatizers, but we raised the flag and said, no, cut the bullshit. Let's put cards on the table, and let's see where we are. So where we are with that roadmap. We have done literature review. We have done the survey. And then the next is actually to do the workshop. The workshop will be done sometimes mid-next year. Actually, Dr. Al-Amoudi and I were officially invited to participate in the workshop, and we will be glad for the next workshop to report what this particular research group have identified as final projects and what is going into this roadmap. So once the workshop is complete, by the end of the next year, we have to actually have the final report that presents all the findings and directions for research. So that's where we are. The other very, very big, so we're talking about $5 million every year. Now, the US government understood that desalination is so critical for the future of our country that they decided $5 million of research for such an important topic is not enough. So Water Research Foundation, you can continue. This is a lot of different stuff that people are looking at, and it's very much what the future will look like stuff. So I'd like to certainly share it with you. Maybe we can break for 10 minutes, 15 minutes? Yeah, if you'd like to.
How is the
Yes.
How is the water completely different fund than the National Science Foundation?
Yeah, National Science Foundation doesn't fund that much desalination work. They fund mainly water reuse, and they fund other conventional water sources. So this is a different focus, mainly on desalination. So those are desalination roadmap.
You get the money from the subscribe.
That is correct.
Some of the states they don't use the desalination.
Yeah, I mean, public utilities, subscribers, because this Water Research Foundation does research for both water reuse and, sorry?
What do you mean about subscribe? The people that...
Yeah, the way it works is, that's correct. Yeah, this Water Research Foundation consists of over 1,100 subscribers. Subscribers are public utilities, various institutions, manufacturers of equipment, consulting companies. Every one of them, based on their revenue, how much they make per year, they contribute towards that fund. Public utilities contribute based on the size of the utility, how much water they produce. So normally a subscriber will contribute somewhere between anywhere as low as about $1,000 as high as $20,000 per subscriber.
The last question is, did we discuss the national risk on the, for the disruption of the service? For the water disruptions, or how is that affected under the risk of...
When you say water disruptions, you're talking about desalination or what?
Is it one of the topics that's been discussed?
No. No, not in, I mean, what you're talking about has nothing to do with desalination. It is related to water supply resilience and reliability, and that is not done by the desalination roadmap. The desalination roadmap focuses on desalination only. We do have the same agency, the same Water Research Foundation has developed a separate roadmap called Water Reuse Roadmap. Because I know we have mixed the two, but that's not how reality works. Water reuse has so many different topics and practically nothing in common, except for the membranes that we use sometimes in some of the installations. So that's why US believes that water reuse and desalination have to be separated into two roadmaps, and that's what we have. We do have two separate roadmaps, not a one roadmap trying to mix things, because they don't, in real life, they don't mix as we expect that we would. So. Okay, so take another 5 minutes, 10 minutes.
How do you do the, how do you make your selection for the consultant?
Yeah, the consultant.
The real procedure for doing
Yeah, the procedure was we prepared our request for proposal where we define what the consultant should do. All those items, how much it will cost them to, so basically they propose how they're going to do the survey. What is it that they're going to do, who they're going to approach to get the information. Second, how they're going to compile it into topics. Third, we ask them, what is the scope? Give us an outline of the scope of the roadmap, of the state report, state of desalination report, and the roadmap. And fourth, tell us how you foresee the format of the workshop itself. So different companies, we had 5 responses, 5 different companies proposing, and they proposed what they proposed to do in every one of those components, and they gave us a cost, a total cost to complete this task. So we selected it based on how robust the proposal was and how much it costed. So the ultimate selection was based on cost and against cost varied between $35,000 and $70,000. We selected the contractor, Corolla Engineers in this case, who is doing that for $35,000. $35,000 to do all the surveys and everything? Yeah. Yeah, the actual workshop logistical event, like renting the room, is not included in their price. I mean, this is only preparing the materials, preparing the presentations, all the technical details, not the logistical details, like, for example, renting a room or renting a hotel and things like that. They're not included in this price. But otherwise, preparing all the technical material, the presentations is included. Yeah, and reports, all the survey. They have prepared an internet site, they mailed, and they asked people to provide information, basically to fill up the questionnaires or go and provide comments on the internet site. So they build an internet site to collect the information and then to compile it. This was all included in that price.
What is your view? Is it possible to do something like this in the country?
Is it possible? Yeah, it is. It is possible. I mean, at this point, they have created state of the status of report. And as I said, the next step is they did survey, and as I mentioned, and also they did the state of science report. And the next step is to do the actual workshop. So they're working on what they do is they prepare the slides that they propose, how they're going to conduct it and the scope and everything. The steering committee reviews it, approves it, comments on it, and then goes along. And then the steering review committee, consultant, and Water Research Foundation also decide on this workshop participants are somewhere between 40 and 50 decide who to invite based on the responses. If somebody just responds, oh, well, I don't care, or just one word, they're obviously not going to invite him. If somebody is proactively provided good information, they'll invite it to participate. So that was kind of the criterion of who you select from the responders, and also from other experts in the field. So that all is done by the consultant. They do all the technical work associated with it. The logistical work, sending the invitations and everything, is done by the Water Research Foundation. So the consultant does all the science-related review, literature review, because everything starts from the survey. Survey defines what the users need. Survey defines what the topics should be. So once we know what the topics are based on the survey, then they take those topics, go back to the literature, and see what in the literature has been done in the last 5 years to 10 years on this topic. And then summarize that and say, okay, well, here's the state of research on this topic. This was done, these are the issues. So for everyone, they define current status of research. This is what has been achieved. Here are the key issues that have not been addressed by research. So that's done for every topic. And those issues are then presented along with all the issues that the individual subscribers brought in as issues to them, as important topics to them. All this is consolidated, and because you have a lot of different input, the consultant first tries to combine that into 7 to 8 teams, like you see here, 7 teams, 7 key components. And then for every team, the steering committee looks at what is it that they're proposing. Does it capture what the subscribers responded? Does it capture the projects and everything else? Based on that, when they prepare the state of the status report, and we send it to all subscribers and say, hey, give us input. Is that what you're looking for? Is that addressing your needs? And every one of those guys can actually mark it up and say, yeah, you have to add this section here, or yeah, you missed this important research here. So that document is given to all the workshop participants as a background document to work from. And the workshop participants ultimately decide what the final themes will be, which teams we'll pursue as research topics, and also what are the key projects under each team. Because of the funding limitation of 5 million, and we wanted not to have less than about 300,000 per project, we were limited to how many projects we could do. So therefore, for every team, through this workshop participation, we got about we plan on having about 40 people, and these 40 people will be divided into 7 teams. So let's say if you have 40 divided by 7, about 6, 7 people per team. They sit, and for 2 days, half day, first day, half day, second day, sit together and build up consensus on this team. What are the 5 most important projects that we need to implement? And for each of those projects, they're required to develop a scope, brief description. What's the purpose of the project? What's the outcome of the project? What is the scope, and how much we think it will cost?
As a research, right?
Yeah, those are research projects. They're, as I said, some of them are research projects in their pure sense. Some of them is fundamental research. Some of them is applied research. I need technology, for example, I need a methodology how to assess carbon footprint. That's more of a practical, not as scientific, knowledge. But so it's a mix of what the utilities need, what the subscribers need, what our industry needs here in Saudi. That's how we find what it is. And then we decide collectively which ones do we give a priority. And the priority is based on which one will benefit most of the users. If a topic we know will be beneficial for everybody, we'll certainly bring it to the top. So the prioritization of this 1 to 5 in each topic is based on how much benefit everybody will see that is participating. So this principle actually is fairly reasonable because at the end, the funds that everybody contributed to ultimately would result in investing into topics that everybody is very interested in. Because many of those companies would participate, we have 40 participants, that gives them their direct ability to impact into the final product and what it looks like. So from that perspective, sometimes research projects are scientific research, sometimes they're applied research, sometimes they're policy research. There was one project, for example, about how do we create a public relation package? How do we go about educating the public on the topic so the public accepts it? Because as I mentioned in the States, unless you convince the public, you're not going to build the project because the public will say no. and doesn't matter who else says yes, they won't accept it. So, the mix of projects is some policy, some applied research, some fundamental research. And I think that's the right mix. It depends on what the industry needs. Yes?
How could we define the subscriber, as you said, or the stakeholder for the desalination technology? Because if we are preparing the survey, and because this is the two important things, preparing the item of the survey, and also define the subscriber or the stakeholder.
Yeah, the subscribers in the States were based on the who's contributed money to that purse of $5 million. Basically, as I mentioned, there were 1,100 members. They're members of the Water Research Foundation. Every year, they contribute a certain amount of money. So those are the subscribers. That's why we call them subscribers, because every year, it's like a subscription for a magazine. You have to pay your annual due. So that's what they do. Every year they pay an annual due, and this money is going towards this research. So they are the first ones to be asked, what do you need? Because they're the ones that pay the bill, as to say. So that's how we define who the subscribers are. Besides that, we also invite, for example, some industries, like makers of pumps or membranes, are not subscribers, but they're important to the industry. So we would invite them as well. Research universities, some universities are, some are not members or subscribers. If we know that a certain university works on a very important topic, we'll invite them also to do the survey. So the survey is not only limited to the subscribers. Subscribers is the core. As I mentioned, this is about 1,100 institutions, but also other experts or manufacturers, or sometimes it's, we actually had invitations to the ministries or the equivalent of ministries, to the local regulatory agencies to provide us with the questionnaires. What are their issues? How do we facilitate the permitting of a project, getting a license for it? They need to have, we need to understand their needs, because often they say, like for example, in the States, we do have requirement for when we build any drinking water project to show that you have certain level of removal of pathogens. We call it pathogen removal credits. And they're given to various technologies depending on what they can do. And like in reverse osmosis, the regulators always say, no, we're not going to give you high credit, although we know reverse osmosis can remove it, because you cannot monitor online how well this membrane works. What happens if the membrane breaks, if there is a puncture, and you get bacteria and other pathogens going through? How are you going to do it? So we said, well, yeah, we don't have that technology. So they said, hey, build it. If you build it, we'll give you a higher credit. Here it is, research need. For us to get a higher credit and recognition, we have to develop a technology. It's a science project driven by a very practical requirement to solve a permitting issue. So those kinds of inputs are very important to us. They don't necessarily mean that we'll be creating a policy. We're creating a solution to a problem that they identified.
Okay, we have stopped now.
Yeah, we can continue on. Yes. Okay, well, the other institution with the real big money is the government in the US. And that is the, as I said, the National Alliance for Water Innovation. What that alliance is actually about 128 different institutions. And most of them are universities, but those are also manufacturers of equipment. Those are also public utilities. They're a very big mix, 108 plus organizations, large companies, small companies. We have companies like me and the company I have in the US, universities, national labs. In the US, we do have an institution, the Department of Energy, which is equivalent to the Ministry of Energy. And they do all the fundamental research in the US on energy topics and other topics. They do all the gadgets for the CIA, for example. They do all the new energy technologies. They do atomic bombs and other nuclear weapons. They do a lot of different things. The Department of Energy has a big purse, a lot of money, that is given directly to the federal government, and they do that research through 14 national laboratories. So we approach those laboratories and say, hey guys, you have all the money, all the fundamental research, please participate. It's important to have your knowledge. Because many of the, as you know, many of the developments in common world, like internet, for example, or cell phones, they were developed by these national labs in the US for the military. And then we made them publicly available. So they do a lot of research, which is very, very critical, very fundamental research, that ultimately, although may have been developed for weapons or other purpose, actually could have a great benefit to the general public. And that's the mechanism to tap into that source of information. So federal agencies would correspond to your ministries. Here, state agencies, that's between the individual states. We have environmental and other agencies involved in desalination. Water utilities, those are the utilities that I mentioned that produce water. And nonprofit organizations, those are the environmental groups that have concerns about desalination. We'd like to have them included as well. Make sure that if they have a problem with lack of science on some topic, to support our claims, for example, for environmental impacts, we create that. The industry creates it. So this consortium, at this point, consists of 3 national labs, and those are the Oak Ridge National Laboratory, the Sandia National Laboratory, and Lawrence Livermore National Laboratory. They're in 3 different locations. Dr. Alamoudi and I have facilitated actually signing a agreement, memorandum of understanding between the Department of Energy and with all their national laboratories and Saudi Arabia, the Ministry of Water. This was about a week ago, where they agreed to work with us to tap into this information and eventually into this money. So that will be a significant benefit to us. For example, when we talk about renewables, we went to visit at Oak Ridge National Lab. That's the laboratory that does all the gadgets for the CIA, for example, and the Secret Service forces and Delta Force and all the other guys. They have developed an amazing reactor that is actually driven by rubidium. It's called fusion reactor that works on rubidium and creates, it's not a radioactive process. It doesn't involve radioactivity or emissions. And it uses rubidium of a size of a pencil that can generate 15 megawatts. Currently, it's used in the special forces of the US as a reactor that drives real equipment, amphibious equipment. But it is very elegant. They showed it to us. They call it the trash can, the size of this lantern, as you see it. It's about the size of a trash can, which can produce 15 megawatts of electricity with no emission whatsoever. Heat, temperature, nothing. And it works, as I said, only on rubidium. Rubidium is a very critical component, of very high importance in the world, and it's only made in China, and we don't like China, as you guys know from the news recently. So they said to us, make us rubidium from seawater, brine, and we'll give you the reactor. And that reactor, what is surprising about it, when we did the simple math, we found that rubidium when you look at 15 megawatts, that can drive 100,000 cubic meters a day plant, desalination plant. 100,000 desalination plant produces rubidium in the brine as much as twice adequate to produce 15 megawatts. So this plant can run completely self-sufficiently on rubidium in the brine and produce another 15 megawatts for somebody else. This is what I would call renewable desalination. So they say, okay, well, give us the technology to make rubidium from the brine, and we'll give you the reactor. So this is the type of research and value that we think we could bring working with those types of arrangements. So Department of Energy and specifically Oak Ridge National Lab and the other 2 labs I mentioned have developed most of the technologies in that field that can be transferred. And we have this mechanism at this point to work with them and transfer this technology for free. The reality is the US government spends tons of money, usually billions of dollars, in developing of those technologies. But if you find a partner, international or US partner, business partner, that can commercialize that technology into military or non-military purpose, in our case it will be non-military, producing drinking water, then they will give you all the patents associated with it for free. It's yours for absolutely 0 pennies. So that's a great benefit, and that's why I'm bringing this program, because it gives also us opportunity as a country friendly to the United States, and also as a country that now has an agreement with the Department of Energy to transfer this type of technology to actually benefit from that. So what is it that this National Water Innovation Center is trying to achieve? They see desalination with 5 challenge areas, and they're shown here on this figure. They see the need for autonomous water. What that means? That means basically desalination is behind other industries as far as automation. If you go to a milk factory, I don't know if you've ever been to a milk factory, you will see no single person running the milk factory. Everything is fully automated, and we unfortunately are not. We are a food factory. We produce water, different food product, not milk, but food product as well. And we are not there yet. So the point is we do have to turn to design the systems, and have to bring our plants to a point where everything is fully automated. It does not require operators, except for maintenance, of course. And even maintenance is centralized. So different model for automation, high level, 100% automation. In the US now, we are striving, like the latest desalination plants are designed for no people at night. We have 0 staff at night. Everything is fully automated. In some states, we do have a requirement for people present because it's a drinking water plant. In some we don't. The ones that we do, we have only 2 people at night, and there's nobody else at the desalination plant. Everything runs itself. That's a goal, and beyond that goal, we're not only looking at that goal, but we also are looking now, and our utilities are looking at centralized control. What that means, there is even no control now in the individual plants. There is one control center that tracks everything and has maintenance teams that are distributed throughout the country in close by, going and taking care of maintenance. Very different concept that they're looking at. Second is precision separation. I mean, the membranes that we have today and other technologies tend to be affected by many factors, and we cannot isolate individual substances that are of value to us. We don't have those technologies, like, as I mentioned, rubidium. It's not very easy to actually develop a technology or membrane that can separate rubidium. It doesn't exist today. Is it possible? Yes, it is, but it has to be developed. So that's the precision separations, extracting specific things at very low cost. Today we do it through ion exchange, which is very expensive. Question is, how do we generate the next generation of membranes that can selectively extract very valuable products like lithium, rubidium, cesium, or calcium, or magnesium, for example. We found that magnesium is extremely valuable product, and it's in large amounts in seawater, because we were talking with NEOM, and Tesla is one of the companies interested to open a business in NEOM, in the NEOM area, and they're asking, do you have source of magnesium? We need elemental magnesium. And why do they need magnesium? Because they don't want to use aluminum anymore in their cars. Magnesium is 30% lighter, so they're switching to that. We talked to Apple, who is also interested in coming in, and they're saying same thing. All the latest computers, although they look like aluminum, they're actually magnesium-based. So magnesium, which is very richly available in brine, costs currently about $3,600 a ton, more than the price of gold. So for the industry, it's so valuable and so important product. So precision separation, extracting particular valuable products that are high valued on the market is very important. Resilient treatment and transport. What does that mean? That means that we do have to be very reliable in our operations. We have to produce water. Currently, when you look at availability, downtime, even in Saudi Arabia or most other plants, we look at 90 to 96%. So that means that the 10% of the time we may have some failure that does not allow us to produce the water that is the design capacity of the plant. They're saying, well, this is not acceptable. We have to make treatment and transportation that's 100% reliable. Because if we want to automate things, they have to be 100% reliable. Otherwise, if you don't have reliable automation, everything goes to hell. Nothing works like it has to. So resilient treatment and transport. And the other issue that is actually very important here to consider, a US government considers, which I think would be valid here in Saudi Arabia as well, is actually safety and terrorism protection. Like, for example, in the States now we're looking at underwater desalination plants, as we're actually looking here with Dr. Al-Amoudi, because they cannot be hit easily by missiles or by drones, by anything else. And that's actually possible. And we're currently working with Dr. Al-Amoudi, with a Norwegian company that brought in some of the technology used for underwater exploration of oil into desalination. We'll be bringing, we already are running a pilot. Well, we made a joint venture with them. We're running a pilot in Norway of the plant. It's been running for 3 months. And it's coming to Jubail next March. So you'll be able to see it. Hopefully next time when we have a workshop, we'll take you out to be able to see it. So that type of resiliency is very important. Intensified brine management, what that means is what we exactly discussed, turning brine from a waste into a valuable product. What do we do to do that and do that inexpensively? Modular membrane systems, that is a very important new concept that is considered the future of desalination. The way the U.S. research institution sees the desalination plants in the future is as two bags of chips, low pressure and high pressure chips coming to the desalination plant. Every component of the plant is made of plastic except for the motors. Every component is made of plastic and printed on site with 3D printers. So the vision for the future is to develop a desalination plant that's at least 80% plastic, and all plastic is printed on site using 3D chips, and they will be only different in chemistry by low pressure piping and equipment and high pressure piping. So it will be low pressure and high pressure piping and chips. And the way they see the desalination in the future is responsive and will be fully obsolete. It will be obsolete even in 10 years from now. So we have to look at how can we regenerate the plant quickly to match it to technology. And the way they see it is we build the most components from plastic, and then once, let's say, this pump is obsolete, morally obsolete 3 years later, there is a much better, more efficient pump. We take this pump, we grind it into chips. If this was a high pressure pump, high pressure chips, low pressure pump, low pressure chips, and those chips are used to print a new pump. So technically everything is 100% recyclable. That is the vision of the future. We do, all the components are recyclable, and what you get on site is no longer you get transportation with huge carbon footprints of moving pumps and equipment and heavy machinery. Everything is printed on site through the 3D printing. That's why in this particular case, this research is putting huge amount of effort and funds into 3D printing every component we can think of a desalination plant. Because they believe that and they are very much engaging the industry to start rethinking how do we make everything so modular that it can be easily 3D printed on site from plastic material, and then recycled, more importantly. Once it's obsolete, morally obsolete, you get 3 years later, you're a subscriber to, let's say, Torishima, which supplies you pumps. You're a subscriber to them. 3 years later, where they have a new pump, they send you over the internet the programming for the 3D printing of your new model pump. So there is no pump being moved from Japan or any other location where it is now produced. It's all printed on site. All they send you is the software to print the new facility. That is the vision. That eliminates the huge carbon footprint of transportation of equipment. It also eliminates the big issue. There was one of the items brought in our roadmap here in Saudi is the spare parts. Often we rely heavily on outside production, outside equipment, and getting spare parts sometimes takes 6 to 8 months. I mean, that's my experience with SWCC, for example. Everybody else is the same way. It's not an issue of that. Yeah. Yeah, this is important.
As cash, for example, now, they come up with pipelines from resin, organic resins. Okay, now we have this in our piping plant. No more stainless steel for piping. Okay, no need for high alloys. Only organic resin now succeeded in our piping plant when we tried. Now this is a ship. This was a dream. But now it's a ship. Okay, it's actually. What's the name? Asahi Kashi is the name of the Japanese company. Okay. Now, for this team, what they are looking for, it's promising for us.
Yeah, Asahi. Yeah. Yeah, they developed the high pressure piping, for example, and it's logical to assume it's possible. As all of us that are familiar with reverse osmosis system, and Asahi is producer of vessels, they say, okay, we can make a vessel for pressure, high pressure. So what is a vessel? It's a pipe. So why can't we make just a pipe and replace all the steel with plastic? And that's what they're doing. And US is looking exactly the same way. Everything that is steel has to be replaced because ultimately this steel is converted into, it's very difficult to recover and reuse. While plastic can be recovered and reused. And even if it breaks 3 years or 5 years later, who cares? We'll print another one. So 3D printing is in the core. And they call it advanced manufacturing. But that's the core of advanced manufacturing, 3D printing. The same thing for sensors. Sensors are no longer purchased from company A, B, or C. They're actually 3D printed on site as well. That is the other direction of thinking of these technologies. So modularity will be very critical because we want to be able to, like Lego blocks, change things very easily.
We have seen it in Saudi Arabia.
Yeah, in Sandia Lab, they have a 3D printer. They have developed actually sensors, and we're going to work with them on that. 3D sensors, simple sensors, which can be installed either in the water or they can be just attached to the pipe, like an outside. If it's for example, a strap-on flow meter, they can strap it on the actual pipe and take a reading. They do not require. They are only $10, and they can be printed. So let's say 6 months later, rather than calibrating, you just print another one. So that way, there is no calibration, there is no expensive replacement. Everything is done on site. The other thing that they developed, which is the new generation of thinking, is currently we use fiber optics. As you know, we have a central control room that gets information from all the sensors, which are physical metal sensors usually. We collect the information, we process it, we send it back, and we use fiber optics. They say fiber optics is stuff of the past. We shouldn't be looking at fiber optics anymore. So the thinking here is they develop sensors that can be activated with a signal from the central control room, which sends the signal, makes the sensor to be activated to take a reading, and the same energy that was sent from the control room is enough to return that signal back to the control room and take the reading. So there is no internet anymore. It's a remote sensing approach. So this is the next generation of sensing that they're working at and looking at as very important. They consider that as part of the modularity and electrification of the system. How do we eliminate the need for expensive equipment that requires calibration and heavy maintenance? The answer is, let's make it cheap and just replace it. Why do we have to even calibrate it? We just print another one. And they showed us actually sensors that they developed, and they 3D printed it in front of us in a simple printer. They printed a $100 bill as well. It looked like a real. And they said, well, you run out of funding? Here it is. It can print anything. But the point is, this sensor is $9,000. We're not talking about this 3D printer. We're not talking about expensive equipment. So all this is possible and done in other industries. When we went to visit Oak Ridge National Lab, you wouldn't believe Tesla, who you know from the electrical cars, they have retained Oak Ridge to develop a 3D printer for their cars. They're 3D printed, except for some components. 90% of the Tesla cars are 3D printed. And that's how everybody looks at printing in the future. You see Boeing with their new engines, huge complex engines, all 3D printed. So the industry now is retaining those labs to develop a 3D printing. We talked to, and the other beauty of it is they not only can 3D print the component. Let's say we need a spare part, and that spare part will take 6 to 8 weeks. It will take about 2 to 3 hours to 3D print. And more importantly, they can figure out what exactly is wearing off and provide a different substance, so often composite material, which could be mix of plastics and metal, to replace that component. So when they 3D print, they not only print, they can print it 100% in metal, as it was, but they can also offer a 3D printing in different composite material that can actually make it more durable. We've been talking with them. Actually, one of the projects we've been focusing on with Dr. Alamoudi is for them to help us, and they're coming early next year, to identify which components in SWCC plants are the ones with the longest lead time. Sometimes we get 6 to 8 months to get a component. Well, we could print it for a couple of hours, and they said, sure. And the high pressure pumps, valves, any component you could think of. And the beauty of it is, the way it works is that electronically goes into the printer and it prints it, it replicates it. So you need the scanner and the printer. And that now exists as technology, and we're not talking only printing a small component. You can, we can print they can print the entire car. The 3D printers for cars are about the size of this room. So the point is, this technology already exists, and we do have to benefit from it because that eliminates the spare part issue. We could print anything we want. We'll have a workshop with our operators, identify some key spare parts, bring the 3D printer here, and start printing everything we need right here in Saudi. That kind of a 3D manufacturing, I think, will be the thing of the future. Yeah. Yeah, you could print every spare. Yeah, and that's the vision of the future. At this point, we will start with one 3D printer, which will be located in our facility. And then, once we prove everything and develop it to a point where everybody's comfortable and we train staff, we'll move one to every treatment plant. So you could print anything you need. You don't have to wait for so many months. I don't know, maybe about 15. Okay, and I'm going to go a little bit faster over what's left. Basically, it explains what is the, who are the leaders in it, what is the funding available. The leader of the entire, there's one leader from the National Labs, the Lawrence Livermore Lab, which is located in California, in San Francisco. They do lead the entire program. And I wanted to talk a little bit more about how the topics are selected. And more importantly also, what are the criteria for project selection? How do you pick? Because you have such a big area of projects you could do. What are your criteria to pick a project and to build and to implement? The criteria are energy intensity, energy per cubic meter of water produced, level cost of water, basically we call it cost of water production, water intensity. This is how many, that's basically corresponding to what we will call recovery. In a desalination plant, as I mentioned, currently we take 100% of water and we recover 30, 35, 40%. How much higher we get will be an important criterion. So if, for example, a technology can recover 75 or 80% of the water, it will be prioritized compared to technology that is not as efficient. Maybe producing the water at the same cost, but it has lower recovery. So recovery of the source product is very important. Then degree of utilization of unconventional water or energy sources. What that means is a project will be given a higher priority if it relies on renewable power. Therefore, renewable power gets a great focus. The more renewable power is used in the process that you're proposing, the more likely it is that you will get funded for you to develop. And then water system security and resilience, risk of disruption and number of days of lost service. As I mentioned, availability, which in the US currently is about 96, 98%, as it is in Saudi Arabia for desal plants, based at least on what we've seen. We are looking at now shooting above 98%. KPI for SWCC is 98% and above, but the industry is looking now for 99 and above. So those are the criteria. So how do we, in every project, when somebody proposes a project, they have to show several very important parameters. What is the typical, let's say, energy use or cost? Doesn't matter what parameter it is. You have to show this. What is the typical? What is the state of the art? What is the best known cost that you, or for example, if this is a cost, you're proposing a technology. You have to show what is the typical cost for that technology. What is the state of the art, the best technology available, what that technology can do. And then the practical minimum, which is how low can we go using existing knowledge and technology, and then the minimum that is theoretical minimum. Like if we take energy, for example. Currently, we know that typical for our plants is 4.5 kilowatt hours, 3.5 to 4.5 kilowatt hours. State of the art is about 3.2, 3.3. This is the best plants in the world are, for this seawater, about 3.2, 3.4. Practical minimum, just if we had the best energy recovery devices in the world and pumps, would be somewhere around 2 or less than 2 kilowatt hours. And then the theoretical minimum is 1.68. So we had 4. So you have to show, when you propose your product, tell me what your numbers are for your product. Where are you? Are you state of the art? Are you close to the practical minimum? Are you, are you shooting towards the minimum? That is very important criterion when you submit your proposal for me to judge how valuable your work is. So the key, they call it pipe parity metrics. That is a very weird term that only electrical guys can come up with. This is Department of Energy. They're not water people. But they're very strong politically, so they got the funding to go through their ministry rather than a different ministry, which is the Department of Interior and the Bureau of Reclamation. It used to be that all the money, federal money, was going to the Bureau of Reclamation and Department of Interior. The Department of Energy is much stronger politically, so now they refunneled all the money to go through them. And they use terms that we don't use. Like, for example, pipe parity. What pipe parity means? What they decided is the goal, and I forgot to underline that, and I'd like to just bring it back to your attention because it's very important. What is the goal of these technologies? The goal is within 10 years, the same as our Vision 2030, within 10 years, to reduce the cost of desalination down to 90% of the cost of conventional water treatment. So imagine, in 10 years, desalination will cost only between 10% of producing water from lakes and rivers or conventional water sources. That's the goal. In 10 years to do 90% reduction in cost. That is a dramatic improvement. So the technologies that we can do this have to be not incremental.
What is the baseline cost?
Sorry?
If you have you are reducing that to about 90%.
Yeah, you would.
The baseline of the cost now.
So you mean drinking water cost or?
I mean the goal.
Yeah, the goal, well, yeah, 90% will be 90% of reduction of, so for example, currently desalination costs $3, sorry, $3 per thousand gallons, $1 per cubic meter.
Okay. So the baseline now is
You have to be 90% of that in the future, which is which will be, if it's $1 today, it will be 10 cents, which is basically what drinking water costs from conventional, from well, for example, or conventional water source in the States.
Then what about the seawater? Is it possible that we can reduce the seawater?
Yeah, I mean, it sounds incredibly difficult, but that's the idea. I mean, you have $125 million to figure it out in 5 years.
10 cents from a river, it's not possible.
Well, it depends.
Based on what?
Yeah, I mean, it depends. I mean, what they're saying is this is not 90% of what desalination is today. Let's say if river water source costs you 30 cents per cubic meter. In the States, it will be 30 to 40 cents. You're allowed to be only within 10% of that. So if river water costs, let's say, 40 cents, you have to bring desalination to not more than 10% more than that. 40 cents, 10% will be 4 cents. So your desal water cost should be 44 cents versus freshwater cost of 40. That's basically, they're looking at 10% of what they call conventional water sources. That will be wells. Even with conventional water sources in the US, that varies. Like, for example, if you...
I see your explanation, but I think when I read this in the produced by non-traditional technology by year 20, so that means...
In 10 years.
The desalination water is above the conventional by 10%.
But 10%, exactly. That's the goal. The goal is because currently it's almost significant. I mean, the difference is usually 2 to 3 times, even more, depending on the conventional source. So the goal is to bring the cost of desalinated water down to 10% of conventional water source, whatever that cost is. Because conventional water sources also differ in price. Like the cheapest source will be a well. You build a well into a freshwater aquifer, that's as cheap as that, only the well cost. That will be about 30 cents in the US per cubic meter.
When you are doing discussion related to the groundwater, like brackish water, what you discussed.
Yeah.
So the main issue for the brackish water is the brine disposal.
Yes, that's correct.
This is the most difficult part. And
That is exactly the case.
They are currently in the kingdom, actually.
And it is in the States. Actually, nowadays, the cost of getting rid of the brine is higher than the cost of the treatment process. It is the same in the States.
Another issue for the kingdom, if you correct me if I'm mistaken, because the radioactive materials ppm is higher than the rest of the world inside the kingdom.
Yeah, absolutely. I mean, that will be an issue that you have to solve because, groundwater, some groundwaters could take. But the idea here is technologies that can allow you to deal with that. I mean, that's the idea. So whatever is the limiting technology, in this case could be brine disposal for inland brackish desal. How do you develop technologies that allow you to deal with that issue very cost effectively? So there is no easy answer to any of those questions. It is basically the way they see it. It is possible by integrated data analysis, modeling, and simulation, process innovation and intensification. This is where the main focus is, and materials and manufacturing. As I said, new methods of manufacturing and new materials.
We have to start, I think, the second session now. Can you please?
Okay. Yeah, I'll go a little bit faster. Okay. Yeah. So we discussed these issues here. as I mentioned, levelized cost, the cost of water, energy use, use of alternative energy, and water intensity, recovery, and resiliency. Those are the key factors to judge how good your system is. Now, what is interesting in the map, in the road map, is besides seawater, as you can see, is one of the water sources. We do also have other waters. So basically, this has to address solving problems with other non-conventional waters, industrial, brackish, municipal reuse, and others. So this roadmap encompasses, besides desalination, encompasses many other sources of water. Just wanted to point it out. And because of that, the roadmap is user-driven. Basically, the roadmap has to generate benefit to the key users. And the key users identified are power industry, resource extraction, that's basically mining industry or extraction of benefits from brine, industry, and municipal water treatment, that's municipal water supply, and then agriculture. So so when we pick a project, we have to make sure the more of this we solve problems in those, the better off the project is. So those are just criteria. So what the product will be of this process will be actually 9 source water baseline studies. So what that means is we want to define what brackish water means, what industrial water means, and what are the key constituents that are troublemakers for us. So those are the source water baseline studies. Then 5 user maps, and those are the 5 water user maps of those 5 users. For every one of them, there will be a separate roadmap developed. And then also there will be a master roadmap that collects all the inputs from all the other roadmaps. That's kind of their system. So how is the actual project developed in this case? Every one of those water sectors that I mentioned, every one of those water sources has a person that is responsible to lead all projects in that source. Most of those guys that you see here, some of you may know some of the people on that list. They are usually professors who are well-recognized professors in the US in this field. In our case, it's a lady professor from University of California, Irvine. You see Irvine that leads the seawater. So they are responsible to ultimately select the projects that are going to be implemented. They're called lead cartographers, again, a term that is very strange for desalination, but they call that person lead cartographer. And that person taps into a source water roadmap team. I'm on the source water roadmap team for the municipal desalination in that case. So there is a group of usually 15 to 20 people that are in that team that are ultimately making the decision of which projects will be selected and where should we go. What is the scope of work for that particular team? So we do about 3 months to review what is needed. We synthesize the result. This is 3 months research means this is survey. That's what it is, similar to the other project. So then we have 3 months to synthesize that survey, and then we will create a roadmap. This is done also through a consultant. It doesn't mean that I'm actually sitting and writing the roadmap. We do have a consultant that was selected by DOE that does that support work, similar to Water Research Foundation. So the steps is, first the roadmap team is created, the one that will be making decision on which projects are going. Then we do interviews and surveys. That's interviews with leaders in the industry and surveys similar to the Water Research Foundation. And then we do workshops. We had, for example, a workshop about 2 weeks ago on the scoping of the municipal water roadmap from that perspective. So that's the methodology being used in this case to create the roadmap. I'm not going to go through the details, but basically, just to summarize it, we have the group of people that are experts in the field. We have the roadmap developed. And based on the roadmap, we actually would develop this team, the roadmap team will develop actually RFPs, requests for proposals for individual projects. And those projects, this $25 million will be spent on this project. So that's how the process goes to funnel those funds into projects. So the projects are usually 1 to 3 years of duration. They're 100% collaborations expected. What that means is we have, if you're selected, your university is selected, you do have to provide in-kind contribution to the cost of the project equivalent to what you're given. Let's say if this project needs $6 million, you have to provide $3 million and I will give you $3 million in cash. That's how it works. That's one of the conditions of how the projects work. And the individual projects could be anywhere between $1 million or $8 million, so they're big research projects. This is the current outline of where we are with the roadmap. The roadmap teams were formed. We went through the interviews and the surveys at this point. In August, we've completed the surveys. We've completed the workshops in September, and then we're in the process of developing the roadmap draft. I expect the roadmap draft to come to my review from the consultants by November. So, and then we'll review it in November, and then publish the roadmap by the end of the year. So there will be a desalination roadmap we could borrow from as far as ideas, and by the end of this year in terms of water reuse. It just gives you. So this is a fairly fast-moving process, because the ultimate goal is not just to create a roadmap, but to create direction of where do we fund this $20 million for every year to spend on new projects to develop. That's the ultimate goal of this exercise. One of the very important issues, and that's where they started with. We started with projects, requests for proposals for intensified brine treatment. It is considered so important that we decided that we need about $8 million to address to dramatically improve the technologies for brine concentration and removal. In this case, the goal is to, we realize, as you pointed out, this is the Achilles, as we say, Achilles heel, you know, the weakest spot in desalination, especially inland desal. So we have to solve it in a way that we could turn brine from waste into a benefit. The other question that the proposal have to respond is, can we derive value from brine? That's what we've been actually doing with DTRI. What is it that we could turn from brine that can be turned into commercial product and sold to the commercial users? Like we talked about magnesium, we talked about sodium chloride. Actually, Saudi Arabia is one of the leaders in the chloralkaline industry. And chloralkaline industry needs sodium chloride. And we've been working with some of the representatives of the chloralkaline industry to actually offer and meet their requirements using producing sodium chloride to actually turn it into commercial product. What is very interesting, when you look at the economics of that project, we're looking at developing a 1 million dry ton per year plant for sodium chloride production for chloralkaline industry, for SABIC and petrochemia. The cost of sales of brine is about $40 million. The cost of water is only $2 million. So as you can imagine, water becomes a side product. It becomes nothing. It becomes a byproduct. Where the value is actually the brine. So as long as you could competitively extract value from brine, that is multiple times higher than the cost of water that you produce. So now we are talking about changing the world of Saline Water Conversion Corporation into Brine Conversion Corporation, because that's where the money is. Let's be realistic about it. So as long as you develop the technologies, brine becomes a very attractive source of value.
Let us give them an example.
Yeah, go ahead.
Selling the water per meter cube is about $1, okay? Whereas the selling brine per meter cube about $12, 12 times. Okay, and we can go also to 15 times, to $15, and they will accept. Just I have received a call from a WhatsApp from a company. They agreed to purchase that for more than, they are now paying $85 per ton.
For the brine only.
And they request a special concentration for the...
Yeah.
With high quality. That's what we are doing.
Okay. Yeah.
Another thing, if you know, Professor Nikolay has addressed, the pre-treatment.
Mm-hmm.
There is a constituent of the bacteria in the proteins.
Sure.
Aquaporin membrane, you mean?
No. During the pre-treatment, normally what we are doing, if we can avoid chemical treatment and we can do the physical treatment, so then we can go through the protein. The protein of this is a source of the energy.
Yeah.
Sure. Yeah. I mean, that's how we kind of have to look at it. We look at it as a waste or as a trouble, and we have to turn around and look at it as product and a benefit. And that's the thinking. I mean, when we were developing this project, it's actually very stimulating to be given like the guys that are buying the brine said, okay, well, we need brine of this quality. And by the way, we need the 250,000 TDS. So this is 250,000 milligrams per liter of sodium chloride, very high salinity. The only way known to man today is to evaporate that. And we actually sat with our researchers and said, okay, well, can we do that by membranes? The first reaction was no. There will be so much concentration, polarization, and it's impossible. And we actually solved all of that. We do have 250,000 milligrams per liter elements now, which even the industry doesn't know anything about it.
We are looking also to 360,000.
Yeah, that will be done different way though, not with membranes.
Now our CDT center.
No, you will start crystallizing in that point. Yeah, go ahead. Solar, sure.
Our
Yeah, go ahead.
center now is working on to concentrate the brine by using a different technology instead of the membrane. We just submitted our proposal. Let's see how.
Yeah, I mean, it's the current approach in the world has been to try to use membrane brine concentration, and the technology we developed in DTRI actually allows us to get to 250 using membranes, which initially, the commercially available elements are hollow fiber from Toyavo, and they can get you to about 170,000 with 3 stages. We said, well, forget it. That's not working. That will be expensive. So we sat with a company that is specialized in membranes, in spiral wounds, and said, well, let's see what are the key problems with Toyavo and how we solve them. So we developed, using as a background seawater membrane, seawater desalination, we developed a new element which is specifically designed for brine concentration. It changes the paradigm of everything, of how the size of the pores, the chemical layers, the support layers, the spacer, everything is changed around optimization for brine concentration. So we were able to get to a membrane that can actually produce 250,000 TDS, which was unthinkable. Today, the single stage can only get you 220. That's what's available in the market. But is it possible? When we talk to Hydronautics, who has those elements in Dow, they said, nah, it's impossible. We said, well, nothing is really impossible. Let's think about it. It's difficult. So that's why we basically spent the last 9 months coming up with it, and now we have actually membranes that do that. So, yeah, we could go to session 2. Well, it's noontime, so would you like to take a break and continue afterwards, or?
It's better to take a break for tired.
Because it's okay with me. I can talk all day.
We were attached to the hotel. Already give them instruction that our break will be at 12:35.
Okay, so we could continue if you'd like.
The second coffee break will be 12:35. I'll start.
So should we continue then? Okay, sure.
I
All
have
right.
a question about
Yeah.
the fund. Is the fund available for international institutions?
Yeah, as long as they have U.S. partners. So the way it works is, in order to tap into the fund, because this was funding, and that's what we're doing actually. We are using U.S. partners, the laboratories, through this MOU, the Memorandum of Understanding that we just signed between the 2 countries. It allows us, and it's not available to every country. It has to be a friendly country to the U.S., and we are. For us, any one of us.
So we can apply the fund for this one. Right?
Yeah, you could apply as long as you have a partner from the U.S. So it has to be a joint venture partnership between a U.S. company and you. You cannot apply directly as you, but it's possible otherwise, and that's what we're planning on doing. We've already talked to 3 of the national labs to do joint projects that tap into this funds.
Actually, because actually there is many institutions in Saudi Arabia that's working in desalination.
Sure. Yeah, absolutely. Yeah, just find the right partner in the States, and you could tap into it.
So, Prof, this fund can be applied anytime, or there is this
Yeah.
specific time?
Well, they do prepare RFPs, as I said, requests for proposals based on the guidelines, the maps, the desalination maps. So those requests for proposals are going to be issued every couple of months. So you have to wait until the next request for proposal comes in. So it's not an unsolicited proposal. Now, there is a different path, and that is if you have a U.S. partner that proposes a particular topic that fits all those requirements, they can instigate a project, even if it's not on the original list. There is a flexibility. If there is value in what you create, and it can be by this, the committee, steering committee says, yeah, there is value in that. You come in with your partner and say, okay, I have this great technology, and have not been on your list of projects. They'll say, okay, tell us, convince us that on those factors you're doing better than anybody else. If you are, they will create a project. The flexibility is there, the money is there. Otherwise, it follows the roadmap defined project. So you could either pursue a roadmap defined project or find a partner that can approach the specific cartographer, in this case, in desalination, and ask, say, I have this great idea.
Question after the session 2, please.
Yeah.
We would like to second part, please.
Okay. Yeah, session 2 is to exactly what we're doing, discuss the scope and activities of creation of our own roadmap here in Saudi Arabia. I presented what other people are doing, but just to make sure, to define the original defined purpose of the roadmap, as it was defined originally, is to assist decision makers in planning and development of desalination water use sector in Saudi Arabia. That, to a great extent, is what the other roadmaps are trying to do. But beyond that, and that is kind of the guidance part of it. This is creating guidance to potential users of the roadmap, how to implement projects. But so this is kind of the main scope. We decided that, and Dr. Al-Moody and I would strongly recommend that. So as originally proposed, we are looking at certain components which you're all familiar with. Those are the individual items. And we say all those items are great, and they're very important to look at the feasibility of emerging technologies and so on and so forth. But at the end, we would like to redefine the objectives to include what you propose, but in addition to that, create actually specific projects, define specific research needs and projects that ultimately can solve all the problems that have been listed. So the first component is more of a guidance and educational. The second component is more, where do we go from here? What is our roadmap to new projects and defining new projects for funding eventually? So the ultimate goal is to elevate Saudi Arabia to the status of world leader in disruptive science and technology. In the US, we start to use this term, and what disruptive means that your technology or science is not going to be just incremental addition to what is known. It will cause at least 25% or more improvement in energy, in cost, or hopefully in everything together. It will be more efficient. So that's how we define disruptive, 25% better than what's state of the art today. So we have been doing, obviously the Saudi and many other countries have developed incremental research that benefits the Saudi Arabia and other countries in general. What we're looking at is to turn this into roadmap for disruptive technologies that make a huge difference in the world, so other people can look at it and say, shoot, yeah, this is really smart. And I think it's a good way to invest into the future. I think we have the same vision as the US. In the next 10 years, we do want to develop a number of disruptive technologies which are significantly, not incrementally, but significantly more efficient. And we see as a vision, additional to what the original scope map was, is to let's identify what those technologies are and how do we find ways of funding them so we could become the leader in that field. So, so what I come up with, and then this is just for discussion, is what are the factors? How do we judge that the technology is disruptive, that it's really better than what's out there? So I identified 11 criteria, and we could discuss those, of course, and that's the purpose of this. First, to reduce cost of desalinated water by 25% or more. That's by definition what disruptive means. So we have to come up with technologies which make big difference in cost of water. Second, decrease specific energy to below 2 kilowatt hours per cubic meter. Currently, it's about 3.2, the best. How do we get that from there to 2? We're not as ambitious as saying only 10% for theoretical minimum, but 2 is a good target, or less than 2. A reduced chemical use, but at least...
What do you mean, because the people is understand, what do you mean by specific energy?
Specific energy use means kilowatt hours divided by the fresh water that we produce, spending this kilowatt hours of energy. So it is kilowatt hours per cubic meter of fresh water produced by the technology.
Yeah. Do you mean that for the entire plant or for the RO only?
Yeah, this is for the reverse osmosis, in general for desalination. It could be reverse osmosis, could be other technology. It doesn't need to be. As long as it gets us below 2 kilowatt hours, anything goes. I mean, any technology.
That's including the intake.
Well, no. I mean, that does not include the intake, because technically when you think about the focus, it is the salt separation is 70 to 80% of the energy today. That's why, yeah, if you include the intake and outfall, they could vary from place to place. And that's why I would say it will be difficult to have a common denominator for all possible intakes and outfalls in this world. This is mainly for the desalination, for basically the actual separation of salts from water. So I would say reverse osmosis, but it could be non-reverse osmosis. It doesn't need to be a reverse osmosis process. Anything that allows us to desalinate for less than 2 kilowatt hours per cubic meter. Third is reduce chemical use by at least 50%. And preferably produce chemicals that we need at the plant only from our brine or our source water. We're already doing that, as you probably know. You know, for pre-treatment, we actually use seawater to generate sodium hypochlorite. For post-treatment, we do the same. This is an example where we could use the seawater itself to generate products. So basically, the desalination plant, either the technology either doesn't use any chemicals or reduces it dramatically, or if it uses chemicals, they're produced on site. We're actually currently working on that and going to introduce it in all plants in SWCC, and that is, for example, calcium and magnesium, which have to be added as post-treatment chemicals. We've developed a technology where we can extract it from brine. So now we are switching all our desalination plants from brine, and that's kind of what we've been focused on, and that's why, the reason why is because this is one way of actually make desalinated water free. As Dr. Al-Amoudi said, if we can sell the brine, we will produce drinking water, but if we can sell the brine, we could subsidize the funds from the brine. We're a public utility, we're not for profit, we're not a PPP. We actually can take the benefit of sales of that brine and subsidize drinking water, bring it down to zero, but real zero, not the 53 bogus cents of Mickey Mouse prices that you see from the privatizing agency that you have. This is all bullshit. I don't know how gullible people can be here. I mean, it's such a simple map. And I don't know. I mean, I have nothing against the manager of that company, but when I see this number, I can just laugh my ass off. I mean, this is so stupid. And it's surprising that people just repeating it and say, yeah, this is the truth. No, it's not. You guys are taken to the cleaners. Let's be realistic about it. And that's why I said, in the States, we have the same approach with privatizers. They come in and give you this magical proposals from using existing technology, and you say, if I add all the mortar, the concrete, the pipes, the piping, I can't even pay for half of that. What are you talking about? And it's all playing with numbers. That's why we said if you have a project, we have to know everything on the table. It has to be publicly known because we're a public utility. We're not hiding from the people. And if you can make it for 53 cents because you do magic with technology, sure, show us the magic, right? If you can magically design the system for this much money, it's yours. But the reality is, I looked at some of those bids, like the first Rabbit Tree bid, 53 cents. I did review. What they give you is the first year of cost of water. When you look at 25-year project, which is what is being awarded to the privatizer, and you take the average 25-year cost is $1.28. But nobody tells you that number. And you wonder why the hell nobody tells you that number, because that's the real number. It's not the 58 cents. You could make 58 cents zero for that reason. And that's what is being reported. You cannot be, I mean, you are a very civilized country. You cannot take this bullshit and publish it. I'm just surprised that you actually do, honestly, and that you allow an agency of that stature to actually do that stuff. You have to be real with people and not bullshit them. So I think this type of stuff, and we need to develop a methodology that allows to see the real cost of water, because otherwise this PPP is being sold to you as a magic panacea, and it's not. Look at us, we're the biggest capitalists in the world, and we have the most publicly owned utilities in the world. 96% of our utility are publicly owned. If it was a good thing, being the biggest capitalists in the world, do you think we wouldn't do it?
You will go.
No, we wouldn't. We wouldn't go because the only time when it makes sense to privatize something is if you don't have the money. If you're poor, you have to borrow. That's how it goes. And if you have to borrow, you're in the hands of the people with the money. And that's what you end up being. Because ultimately, those guys can have access to capital that you may not be able to. And that's the only difference. And that's the only difference they do. They don't do magic technologies. Look at their technologies. That's why I'm saying, when somebody makes an announcement about this cost of water, they have to put everything on the table and not just take the public for stupid. And you just do the simple math. You know what the cost of power is. You know how many kilowatts they use because they publish it. And you see it's more than 53 cents. So what's the bullshit?
That's the guarantee price. That's the problem.
That doesn't mean anything. Guaranteed means nothing. Because public-private partnerships are partnerships that can bankrupt. They create special project companies. They can bankrupt them tomorrow. They are for profit. They're not going to exist because the public is nice. Yeah. I mean, it is very surprising that this country is kind of looking at that and actually publishing this stuff, because the rest of the world looks at you and says, guys, are you guys stupid or what? I mean, you shouldn't publish this kind of information because it makes your country look like you don't know what you're doing. And I know you do. The problem is a lot of the information is being hidden from the general public to misleadingly present public-private partnerships as a magic panacea that solves all of your problems. But that's not the case. So be realistic about it. And also, one thing we have to recognize, though, private sector has a lot of benefits in terms of being efficient in operations. That is one big difference. They're very efficient in operating plants. They have ways of cutting down various limitations that we have in public procurement. And they take advantage of every one of them. They take advantage of free market, and they certainly are efficient. We have to recognize that. Those efficiencies we could learn and use. And if there is no ability for us to do it today, it's because we have regulations that limit us, and they don't have them. That's the only difference. But we develop those regulations, not the private sector. We can remove them if we want to be competitive. We just need to recognize the differences. That's why I recommended this. One of the things to do, and you'll see later on, is benchmarking. Let's benchmark against the private sector. See where they're different, really. And focus on those differences and see if we can do it. I mean, that's the reality of life. All right, so let's continue on. So one of the issues is the ZLD. The other one is extract valuable minerals. As I mentioned, that will be helpful. Digitize desalination, design, operation, and maintenance for full automation. I think full automation should be our goal as well. Use renewable energy and reduce desalination carbon footprint at least by 50%. Increase desalination plant availability and reliability to 90% or more. I mean, in our case, the goal is to really get to at least 98 or 99%. Adopt 3D manufacturing for existing outside production or equipment and spare parts. This is what I mentioned previously. I think this will be a very important direction for us to go and address the spare part issue, and in general fit to the future, where everything will be modularized and 3D printed. We have to be ready for the future. Can we implement can be implemented to increase local content in terms of production of critical plant components? What this says is, okay, I have this technology. Can we make this, whatever that is, technology, membrane, component, pump, energy recovery, can we make it here? That, to me, is going to be a very important parameter of saying, yes, this is a good project because we not only are inventing it, but we could actually produce it in Saudi Arabia. So local content is one of the certainly the key goals in this country. So what is it that I would propose as a process, which I think fits to what the original documentation that you have been, you've seen being distributed. One is to establish a steering committee to move along with the process. Procure consultant, I would recommend that because of the writing and organization. And as I mentioned, we're talking about 35,000, maybe 40,000, something like that. Probably won't be more than that. Complete research needs survey, and that will be for the same reason, to identify key research needs. Define state of desalination report, and I see that report addressing all the issues that were already listed in the original document. What is the current status? What is the best in class? That will be the state of desalination for those particular topics that were identified by our own industry as the most important ones. I don't think we want to do for everything, but the one that our subscribers, our fellow members of the industry say, those are the key issues. We need to know what is the state of the art of science on that issue, and where do we go from there. So that's the state of the desalination report. And then create desalination roadmap workshop. that's where all those topics and input is turned into actually defining a selective number of topics and projects. So identify key research topics, define and prioritize projects for each topic, and outline scope, deliverables, and budget for each project. So we know exactly what it'd be. So we could take that and actually carry it to potential funding sources and say, hey, Mr. Source, we collectively as industry decided that this is an important project, and we think your ministry or your investor can fit that need. And here it is. It is something that's not decided by me as Nikolay or by Dr. Alamoudi as Dr. Alamoudi. It was decided by the industry, and I think that brings a lot of value. Many investors do like to see that, rather than, because they always get somebody coming and say, hey, I have the best technology in the world, please invest in it. It's very different to do that versus to say, hey, this consortium of companies and experts in Saudi Arabia said those are the projects. So you have the certainty that what you're being proposed is not just kind of a Mickey Mouse fantastic stuff. It is something that's vetted by the best minds in this country. So I think, and then finally prepare the report, and that desalination roadmap report can be used for both educational purposes as a guiding document and also for investment as our investment tool to pick and prioritize projects. So recommendations, steering committee to have 5 to 7 members. Key functions of the steering committee is to procure consultant, to review all the deliverables and the roadmap report, and lead the discussions of the workshop and prioritize topics and research projects. Ultimately, that will be selected into the final roadmap. So selection of consultant, we can do that through procurement process, public procurement. Everything is open. The proposals are received and reviewed. Consultant is selected and retained to conduct the project. Then next step is the needs survey. So the consultant will develop a questionnaire which will be reviewed by the steering committee and approved by the steering committee. And then it will distribute the questionnaire, collect and tabulate the results, and prepare an initial set of research topics that came from the input from the industry. Questionnaire to be sent to collaborating research organizations, such as the Center for Excellence. I mean, this is the list that already have been prepared. And I added also, besides those key sources of good information, I suggested that we have members from the power industry, Aramco and others that are in the power business, power generation, oil, resource extraction. That's actually Aramco. It will fit better in that box. They extract oil. Industrial manufacturers, municipal. That's the SWCC and other producers of municipal water, as well as the National Water Company. And then agriculture. I think we need to bring the agricultural users along with us because we could carry value to them. We've been developing a project where magnesium extracted from desalination brine is used for irrigation of mangoes, for example, because the value of the magnesium sulfate in it is cheaper than actually buying a magnesium fertilizer. So just an example where we could engage the agriculture industry and say, hey, we have certain values for you. Let's discuss where we can work together. Yeah, and we're working with the center in Jazan actually to develop this project. Yeah. So as I mentioned, questionnaire to be sent to the Ministry of the Environment, the Saline Water Conversion Corporation, National Water Company, Electricity and Water, and so on and so forth, with potentially adding other members to enhance the input on the key topics that people are interested in. So consultant prepares State of Desalination Report, which presents the overview of the current status of science and technology, key topics of disruptive desalination research. Where should we focus to create major input? Initial list of potential projects, and steering committee reviews and approves the report, and then that report is used to develop the materials for the workshop, which ultimately will be the workshop itself. I recommended some format that we've used in the States before. The first day morning, we have a research topic definition. Everybody that is invited to that workshop, typically 40, 50 people, would look at the results of the national research survey, what is being identified as topics, discuss it, have a whiteboard like this, maybe add a topic, remove a topic based on the input. Maybe we've missed something. And then formation of work groups of 3 to 5 participants, one for topic. And then that work group will be then getting into the details on the individual topic. So the first day in the afternoon, the work groups define projects within each research topic and identify at least top most important issues, challenges to be solved, and potential projects to solve those challenges in the individual topics. And then the second day morning, the work group prioritize projects. They sit again together, prioritize them from 1 to 5, and then define their scope and budget. What do we think it will take to do it, and what should be included in the scope of that project? And then in the afternoon, everybody, all the work groups, presents their findings, and then we collectively decide what is the final set of projects and topics that we need to include. So that's kind of the process that ends up with all the key decision making on research priorities and topics and specific projects within them, with cost numbers, so that way, once we have that report, we could take it to various funding sources and agencies and say, well, this is what we collectively as industry decided, this is what we recommend, this is the scope of the project, this is the budget. Please find the funds for it. Yes. That's the thinking behind that. So consultant prepares the roadmap report, and that is used to ultimately fund projects. So this just summarizes. Step is establish committee, procure consultant, complete research needs. Then 4 is create state of desalination report, desalination workshop, and then the final roadmap report. That's what's being proposed. One thing I would suggest, and that's again up for discussion, is desalination has so many topics and so different from water reuse based on, in US I've participated in a number of water reuse projects, that my recommendation would be, because they're different, although they may address the same users, as you could see here, I would recommend for us or another body to develop also a separate water reuse roadmap. Because I think desalination and water reuse in this country are in 2 different positions, in 2 different places. And what is priority in desalination may not necessarily be a priority in water reuse. Although some technologies could be used for both, no doubt about it, like membranes, for example. But outside of that, the methods and technologies used in desalination in the US, for example, have evolved into specifically, we call it fit-for-purpose waters, which means waters that are specifically reused waters for agriculture, and agriculture of crops that you actually are in touch with your hands, others where you're just like a cotton, for example, where you don't have consumption of the product, or also for cooling purposes, different water qualities, different treatments. The same is true for direct and indirect potable reuse. In the US, that's becoming a very important topic. It's not here yet, but it will come. And then the latest thing we do is actually in water reuse is looking at technology where we have joint desalination and reuse for various benefits. Would that be energy gradient or others? So that's basically my suggestion, or my this is a draft food for thought. It doesn't mean that that's what we would accept, but it's something for us to discuss and see, is that fitting what you think our needs would be, or should we do something different? Beyond that, I think it's a good time to break because it's 10:35. I came up with some additional focus areas that are me. It doesn't mean that that has to be what we do. I can go over those to see what I think personally would, in our case, the important topics would be. But I think at the end, this will come from the survey. I mean, I may be one of the many people surveyed, but ultimately this has to come from the survey, what the industry needs. We need to find that through a very structured process, so we make sure it is inclusive. Why is it important also to come from the industries? Because once people see that we've taken their input, they will be more willing to implement what we have. Otherwise, if we just say, hey, here is the roadmap, go do it, they will be much less comfortable with that. So this is my view on it, but it doesn't have to be our view. I think we will have to arrive, the best way to arrive at this is by tapping the industry resources that we mentioned, and do the survey, and then do the workshop, and discuss this openly through review by the industry as a whole. With that, I think it's 12:35, so a good time to break. If you'd like me to go over what I think are important topics, they're not that far from what you've seen from the Water Research Center. We could do that in the afternoon, or we could start working on other issues. So